Hello, Vanakkam, Namaste, and welcome to Problem Solving for Effective Mathematics Teaching and Learning. I am Dr. Jayanti from Experiential Math Solutions. From this video, we learn how students can have fun while doing some Fibonacci number magic and how we can extend their thinking by asking the students to verify their findings algebraically. After learning a Fibonacci sequence, how to uh, generate terms in a Fibonacci sequence, students can be given this number magic using Fibonacci sequence. Ask them to write the first 7 terms in a Fibonacci sequence, say 2, 3, 5, 8, 13, 21, 34. 5 is generated by adding the previous 2 terms, 2 plus 3. And 8 is generated by adding 3 and 5 and so on. Now ask them to multiply the 7th term by 11. 34 times 11 gives us 374. Let us ask the students to find the sum of the first 10 Fibonacci numbers of this sequence. Let them continue the sequence and find the sum. Students will be surprised to find that the 7th terms multiplied by 11 gives the sum of the first 10 Fibonacci numbers of their sequence. To try with another sequence. And then ask them to show why it is always true. Let x be the first term, x plus k be the second term, 2x plus k will be the third term, and what will be the 7th term? It will be 13x plus 8k. And ask them to find the sum of first 10 terms, which will be 143x plus 88k. Now when the students multiply 13x plus 8k by 11, they will get 143x plus 88k. That is why whatever may be their Fibonacci sequence, they will get the 7th term multiplied by 11. They will get the sum of the first 10 terms of their sequence. We can ask them to play another magic. Ask them to write vertically a Fibonacci sequence, one below the other. And then ask them to draw a line in between any two numbers. Now we will draw a line between the 4th and 5th terms of our Fibonacci sequence, 4, 7, 11, 18, 29, 47, 76. Ask them to find the sum of all numbers above the line. 4 plus 7 plus 11 plus 18 is equal to 40. Ask them to subtract the second number from the top from the second number below the line. In our case, 47 minus 7. That is also equal to 40. Is it always true? Let us try again. We take the same sequence, but now we draw the line in between 11 and 18. Find the sum of all numbers above the line. 22, subtract the second number from the top, from the second number below the line, which is 29 minus 7, which is also 22. Can we check again why it is always true? Let x be the first term and x plus k the second term. Let us write down all the terms in a vertical order as before. X, x plus k, 2x plus k, 3x plus 2k, and so on. Now we draw a line between the fifth and sixth terms, between 5x plus 3k and 8x plus 5k. Let us find the sum of all the terms above the line, which will give 12x plus 7k. X plus k plus 2x plus k plus 3x plus 2k plus 5x plus 3k is equal to 12x plus 7k. Let us subtract the second number or the second term from the top, from the second term below the line, which will be 13x plus 8k minus 8x plus k, which will give 12x plus 7k. Students will be surprised, but they will understand that whatever may be the Fibonacci sequence, whatever may be the first term or the difference, they will have this result true. Now we will ask them to find the sum of squares of Fibonacci numbers. f1 squared plus f2 squared plus f3 squared and so on is equal to what? We can ask them to express it as a Fibonacci number or in terms of Fibonacci number or numbers. f1 squared is 1 squared, which is 1. f1 squared plus f2 squared is 1 squared plus 1 squared, which is 2. f1 squared plus f2 squared plus f3 squared is 1 squared plus 1 squared plus 2 squared, which is 2 plus 4, 6. 6 is not a Fibonacci number. f1 squared plus f2 squared plus f3 squared plus f4 squared is 1 squared plus 1 squared plus 2 squared plus 3 squared, which is 15. We have to find now what is the relation. As 6 is not a Fibonacci number, we will try to express it in terms of Fibonacci number. So I write 2 times 3. Then I can find that f1 squared plus f2 squared plus f3 squared plus f4 squared is 15, we said earlier. That is, can be expressed as 3 times 5. Now, when it is f1 squared plus f2 squared, it is 1 times 2. f1 squared plus f2 squared plus f3 squared, it is 2 times 3. 2 is third Fibonacci number. So f3 times f4. Now let us see if we have to generalize what will be the result. It will be fn times fn plus 1. For younger students, we can simplify this problem The sum of squares of first two Fibonacci numbers, f1 squared plus f2 squared, is equal to 1 squared plus 1 squared 2. f2 squared plus f3 squared, the sum of squares of second and third Fibonacci numbers, is equal to 1 squared plus 2 squared, which is equal to 5. Ask them to extend this and find the pattern. Ask them to express the result, their findings, in terms of a Fibonacci number. Can you predict what Fibonacci number will be f6 squared plus f7 squared? Now, f1 squared plus f2 squared is equal to 2, which is a third Fibonacci number. f2 squared plus f3 squared is 5, which is fifth Fibonacci number. f3 squared plus f4 squared is 13, which is the seventh Fibonacci number. So f4 squared and f5 squared, without finding the number, we can identify the pattern and guess that it should be ninth Fibonacci number. 3 plus 4, 7, 2 plus 3, 5, 1 plus 2, 3, and so 4 plus 5, it should be 9. And f6 squared plus f7 squared also should be equal to f13. And if we want to generalize the result, fn squared plus fn plus 1 the whole squared is, as a Fibonacci number, it should be f2n plus 1. Again, for higher form students, we can ask them to prove it algebraically. Now we can ask the students to find the sum of odd Fibonacci terms and even Fibonacci terms separately, meaning that they have to find the result of f1 plus f3 plus f5 and so on. What will be the Fibonacci number? We have to express it as a Fibonacci number. Also, if it is even Fibonacci terms, f2 plus f4 plus f6 up to f2n. This is a little bit difficult, so I have given the result. It should be f2n plus 1 minus 1. So we can ask them to show it, to verify it. Let us see how to work. Sum of odd Fibonacci terms, f1 plus f3 is equal to 1 plus 2, which is 3. Sorry. f1 plus f3 plus f5, which is 3 plus 5, 8. When we add f7 to that, it is 21. 3 is fourth Fibonacci number. 8 is sixth Fibonacci number. 21 is eighth Fibonacci number. So if you see that 1 plus 3, 4, 1 plus 5, the first term and the last term, f6, f1 plus f7, f8, f1 plus f2n minus 1, because it's odd Fibonacci number, then the result will be f2n. When we do even Fibonacci terms, summation of even Fibonacci terms, f2 plus f4 is 1 plus 3, 4, which is not a Fibonacci number. f2 plus f4 plus f6 is 12, again not a Fibonacci number. f2 plus f4 plus f6 plus f8 is equal to 33. Now 4 is 5 minus 1. 5 is a Fibonacci number. And 12 is not a Fibonacci number, but 13 is a Fibonacci number. 7th Fibonacci number. So f7 minus 1, and this will be f9 minus 1. f2 plus f4 is equal to f5 minus 1. f2 plus f4 plus f6 is equal to f7 minus 1. f2 plus f4 plus f6 plus f8 is equal to f9 minus 1. So if it is up to 2n, 4, 5, f5, f6 up to f6, when we find the summation, it is f7 minus 1. When we do up to f8, it is f9 minus 1. So when we do up to 2n, it is 2n plus 1 minus 1. Again, we can ask higher class students to prove these results. These kind of questions ask the students to prove something that they have not learned in the classroom. Make them think outside the box. If you want to know more non-traditional problems, join our course Experiential Math Content Creator. You can subscribe our channel, and I am signing off. This is Dr. Jayanti from Experiential Math Solutions. Thank you and goodbye. Stay healthy.